Good morning, everyone, and welcome to the Vehicle Weight Management Strategies webinar. My name is Jens Hellberg. I'm the Managing Director of TruckScience. This webinar is for people with an interest in vehicle weight management and who are interested in hearing more about the TruckScience Axle Weight Calculator. We are joined by NTA members from a wide range of companies, including chassis, body, and equipment manufacturers, distributors, upfitters, fleet management companies, utility companies, and local government. As a bit of background, we partnered with NTA in early 2019. They saw a need to provide members with the next level solution to their own free calculator, and since then we've a good number of members have signed up with us. Some of them going as far as to say it's been a game changer for them. Before we get going, there are just a few housekeeping items I'd like to draw your attention to. I'm joined by my colleagues, Sarika and Martin, who will moderate the chat and help with your questions as we go through the session. Now let's get started. So we're going to work through two case studies where we'll look at strategies for managing weight. Specific examples of these strategies are modifying wheelbase, adding axles, adjusting rear overhang, optimizing tongue weight, and considering center of gravity in the design process. In our first case study, a construction company is looking at upgrading their fleet. They have a requirement to move 34,000 pounds of gravel to and from a construction site, and would like the option of towing a backhoe to and from the site. They would also like the vehicle to be useful to them in the winter months where they don't do as much construction. So would like to repurpose it by adding a snowplow and a spreader. Our brief is to spec a new truck that satisfies all of these requirements. So let's dive into the app to see how we might achieve that. Since the customer is purchasing new vehicles, it pretty much gives us a blank slate in terms of vehicle selection. So we should work through their parameters and using a number of models until we arrive at the optimal solution. But since we're a bit limited for time, I'll choose an international 6x4. Now, before we get going with the case study, I'll just point out a few of the design elements on the screen. As you can see, it's brought up a drawing of the International with its standard front and rear chassis weights. These are from the standard spec, but if yours differ from the standard spec, you can always alter them by clicking on the number and changing them there. At the bottom left of the screen, we have the compliance scorecard, which gives us an overview of where we're at in the design. Since we only have a bare chassis at this stage, we're all good. Over towards the right of the screen is our weights table. This gives us a breakdown of all the relevant weights, as well as the permissible value. So this is the lesser of the manufacturer's rating, or the GAWA, and the regulation, which in this case is the US Federal Size and Weight Regulation. On the right-hand side, we can choose between different views of our design, like side and top view, bridge view, center of gravity, turning radius. But we'll see all of these elements in action a bit later. On the left-hand side, we have the menu where we can edit the vehicle, add bodies, equipment, trailers, and payload. So let's go ahead and add a body now. As you can see, there are a number of different body types, but we'll select the dump body as per the customer's requirement. Now we could upload a DXF drawing of our body if we had one, but since we're still in the design phase, I'm going to stick to the template, which gives us total flexibility in terms of weights and dimensions. So I'll go ahead and give this body a name. I'll call it dump And I'll just customize it to our operation. I'll make it an 18-foot body, and I'll increase the height a bit to cater for all that gravel that we're going to cart. Now, our customer has a preference for aluminum bodies. So I'll select a guideline pound per foot value here for heavy duty aluminium. This is obviously just a guideline that would need to be confirmed with the body manufacturer or with the design team. And the last thing here I'm going to do is just move the load center slightly forward because of all the hydraulics that are located towards the front of the body. I'll then position the body nice and close to the cab, so maybe 3 inches, something like that. Right, now that we've added the body, let's have another look at the weights table to see where we are. We can see that there's still capacity on the front axle and overall, as these are highlighted in green, and we can see that the rear axle is the limiting factor because there's zero remaining capacity on this, on the axle there. The app has calculated that we can legally carry around 23,000 pounds, which is well short of our requirement of 34,000. So we can start addressing this issue by extending the wheelbase because the allowed weight across consecutive axles increases with the number of axles and the spacing between them. So let's see what effect that has. So I'll go from a 196 inch to 213 inch, which then lines it up with the body. But the hinge point is quite far past the rear axles. So and obviously when designing a dump truck, it's important to take the stability of the truck into account when the dump is in the up position. So let's address that by increasing the wheelbase and reducing the rear overhang. Something like that. Now that we've changed the wheelbase and rear overhang, it's likely that the curb weights will have changed. So I'll have to get in touch with the dealer to get confirmation of that. And once I have these, once I have these values, I can either update them directly in the calculation myself, or I can get in touch with the support team and ask them to add an additional spec of a vehicle with my measurements. So I'll go ahead and do that, and I'll say, please add an international with 232-inch wheelbase. So I'll send that off, and I'll wait to hear back from them. In the meantime, looking back at the weights table, we can see that the legal payload has actually decreased significantly. It's now just over 5,000 pounds. So why is that? It's because the load center of the body and the payload have moved forward in relation to the rear axle, and more of the weight is now being carried by the front axle. And we can see on the weights table that the front axle has now become the limiting factor, as there's 0 pounds excess. So it looks like we're going to have to upgrade this front axle. So I'll upgrade that, and I'll choose the 14,000 pound axle. And you can see there, Martin has got back in touch to say that he'll add that model for me. So that's great. I can just minimize that. Now we can see that while the payload has increased to 25,000, the front axle is still the limiting factor. So I'll go ahead and pick an even stronger axle, and I'll make it a 16,000 pound axle. And we'll notice then that the limiting factor then shifts to the rear axle. So we've got available capacity on the front. So now the payload is up at around 28,000. So we're getting there, but still not enough to satisfy our requirement. So again, bearing in mind that the allowed weight across consecutive axles increases with the number of axles and the spacing between them, let's go ahead and add a pusher axle and see what happens. Note that adding the pusher axle has given us an extra few thousand pounds. It's jumped up to 32,000. So the last thing we can do here is we can instruct the driver to load the gravel slightly forward of the center of the body. So I'll tweak that and set it to 45%. And you'll see we've just about snuck in over the 34,000 pounds that we need. Now that we've achieved the payload, let's revisit the front axle that we upgraded. And note that we now have a good bit of spare capacity on the front. It's over 2,000 pounds, so we can go back to the 14,000 pound axle, which will save us a bit of money and won't have an effect on the payload. So people sometimes assume that you're able to load a vehicle up to its GVWR, or gross vehicle weight rating, which in this case would be 66,000. Our total unladen is around 22,000. So if we load the difference, which is 44,000, and see what happens, you'll notice that everything lights up and it generates a whole lot of warnings. All the axles and the total have been overloaded. And we've overloaded the bridge and the manufacturer rating in some instances. If we go to the bridge view, we can see it's the rear axles and the total that are the problem. So let's go ahead and undo that change. So now that we've spec'd the vehicle and it fulfills the first requirement from our customer, we might want to send it on for their approval. So let's generate a preview of the design. And we'll tweak a few things. We might add their name here and a few notes. Remember to load the gravel towards the front. And we'll just refresh the PDF. And we can then email that onto the customer for their approval, or make a printout or download a PDF. So space is often quite tight on a construction site. So I'll just have a look at the turning radius for this vehicle. The thing that influences the turning radius the most is the wheelbase. Now we've gone for quite a long wheelbase to accept the load that we've been asked to cater for. Now if you just make a note of that, the turning radius numbers there, and as we reduce the wheelbase, we can see those turning radius numbers decrease. But you'll also note that our payload now has gone down from 34,000 to just over 30,000. So that's not going to do it for us. So I'll just go ahead and undo that change. So now that we've got the payload covered, let's have a look at the secondary requirements of transporting a backhoe to and from the site. Typically, the truck would travel to and from the site empty. So let's raise the axle. And we'll note that the capacity then has dropped down to 21,000 as a result of raising that axle. Now I'll go ahead and add a hitch. So I'll just search for a Holland, and I'll just drag it into place there, just neatly in under the chassis like so. And I'll add a beaver tail trailer, which I've created myself previously. Now, if we had a bit more time in the demo, I could have built this from the ground up, but I'll just select this now to keep things brief. And then lastly, we need to add the backhoe that the customer has asked for. We'll throw that on the back there. And you'll notice the tongue weight is just over 2,300 pounds. So we generally aim for between 10 and 15% tongue weight of 10 and 15% of the overall trailer weight. So that's unladen plus payload. So in this case, the unladen is just over 9,000 and the payload about 14.5. So it's pretty much dead on 10%. So that's you would have to double check that with the hitch manufacturer just to make sure that that's acceptable, that the 10% is acceptable. But generally, it ensures stability of the vehicle and traction on the vehicle's driven axles and the trailer's axles. If we were to load this backhoe slightly towards the rear, you'll notice the tongue weight drops significantly and goes underneath that safety threshold. So it's obviously very important to load this correctly. So we'll just go ahead and undo that and get that legal again. Right. So let's I suppose before I carry on with repurposing the vehicle for winter, are there any questions there yet from?
Jens, there's just one suggestion, really, more than a question. Craig said he would love to also have the top of frame to the top of cab measurement in the future. So I've just explained there on the chat the way we work. I've noted Craig's suggestion and tagged it in our product management software. We release updates to the app about every 2 or 3 months. And then the more people that request any given feature, the more likely it is to get done, or the quicker it gets to the top of the queue. So we do very much encourage you to submit your ideas through the chat in the app or in any other way. And just rest assured that we do record them and we do consider them every time we decide on what we're going to work on next.
Let's go ahead and repurpose the vehicle, and to do that, I'll remove the trailer, and I'll add the snowplow. And now you'll notice that the front axle has become the limiting factor again, and that's obviously because the snowplow is past the front axle, but that should be balanced out. As we plan to add a spreader that will kind of move the load center further towards the back. So let's go ahead and add that spreader. I'll just go into the other category and search for a spreader on the back, and I'll just drag it into position around about there. Right, now we need to remember to change the payload center of gravity of the dump body, because we've now loaded a spreader and some salt. So I'll move that back again. And I'll just drop that front axle. Or rather the pusher axle. Beg your pardon. And you'll see that our capacity is about 28,000 pounds of salt. So at 1 cubic yard of salt weighs about 2,000 pounds. So that means we can carry 14 cubic yards. So that's not too bad. Okay, so that's it for the first case study. Are there any more questions at this stage?
Yeah, Jens, there's just another question that's come in now. Does the system allow for axle back and axle forward configurations? So the way we deal with that is we would add the axle back and the axle forward configurations as separate vehicles in the database. And you can open either of them then when you launch that first screen to choose your vehicle.
So in our second case study, a utility company owns an existing truck that they would like repurposed. They want to add a water tank with pump, hose reel, and some tools. They've also had some historical issues with center of gravity, so they'd like us to pay particular attention to that during our design process. So our brief is to maximize the carrying capacity of the tank while staying within acceptable center of gravity limits. So let's dive into the app and get going with that. So for this case study, we'll assume that that the vehicle our customer is standing in their yard is a Kenworth T880 6x4. And now the customer wanted us to repurpose this into a water tanker. So I'll go ahead and select the water tanker template. And I'll give it a name so it appears nicely on our weight analysis. And as per the spec, we have to add a water pump. So before the session, I imported a water pump from a DXF file. So similarly, you can also do that if you have DXF drawings of any equipment that you want to do analysis on. You can import that through our import wizard. So I'll just go ahead and select that and add it to the vehicle, attach it to the chassis around there. And then now the other element of the spec was to add a hose reel and toolbox mounted at the rear of the vehicle. So to do that, we'll need to make some space. I'll just reduce the length of this tanker around about there, and I'll add the hose reel. Now, this particular hose reel, it's a custom product. So I don't have a DXF drawing for it. So if I don't have the drawing, I can just add it as a template piece of equipment, which basically means it gets added as a rectangle, which we can then customize. I'll just call this a hose reel, so it gets specified correctly on the weight analysis, and I can customize that and make it 1,000 pounds. And I can then drag it into position. So the only difference between the template and the imported DXF, obviously, is the way it looks. The calculations will still be 100% correct and everything. It just won't look like a hose reel. So I'll drag that to the rear of the body, and you can see as I'm dragging it, the weights table is updating. So it's a handy way of seeing where the optimal position for that piece of equipment is. But I'll put it towards the end of the chassis there. And then lastly, we need to add a toolbox. So I'll just add a sample toolbox, and I'll drag it to the back there and mount it on the chassis. So before we move on to the payload, let's have a look at the top view of our drawing and make sure that everything is correctly positioned. And you can see now that the pump has been mounted to the center of the chassis. So I'll just drag that down so that these components lateral positioning will also be taken into account when calculating the lateral center of gravity. So now, if you remember, our brief was to outfit the truck to carry the maximum amount of water. We can see currently that we can carry about 10,000 pounds, which translates to around 1,200 gallons. So we'll probably need to do a bit better than that to make the boss happy. So let's get a bit more ambitious and set that to 4,000 gallons. So at 8.35 pounds to the gallon, that's around 33,400 pounds. And immediately everything lights up to tell us there's something wrong. So what do we do about this? We can look at the weights table and to see where the problems are arising, and we can see that on the front axle. The front axle is really badly overloaded, more than 5,000 pounds. And if we drill down to this limitation, we can see it's the manufacturer rating of the axle that's the problem, and not the bridge. And in our previous case study, we just upgraded the axle, but in this case, because it's an existing vehicle, it's not as easy. So we'll have to look elsewhere. We can also consider extending the wheelbase to increase the allowed weight, but again, that's not as easy with an existing vehicle. So the easiest thing to do here is for us to add a pusher axle. So let's go ahead and do that. And immediately things start to look a lot better. We're still overloaded overall and on the front axle, but at least some of the axles are now looking like they're legal. So what do we do about this? We need to shift the payload more towards the rear of the vehicle. So one way of doing that is to reduce the length reduce the length and increase the height of the tank, so we can still accommodate the same amount of water, but occupy less horizontal space. But before we do that, let's have a quick look at the center of gravity calculation, because our customer wanted us to pay particular attention to that. So we can see the vertical center of gravity measurement there is just about 65 inches. The vehicle manufacturer will have guidelines around this, so it's important to make sure that we stick within those guidelines. And also note how each component of the vehicle has its own center of gravity, obviously, and that gets taken into account when calculating that overall value. So now let's get back to modifying the length and height of the tank. So we'll go ahead and reduce the length to about 181 inches, around there, and we'll increase the diameter of the tank, something like that. Now we can afford to drag that the tanker body back, and as you can see the weights table being updated as I drag it. And eventually, as we get further away from the front axle, that front axle becomes legal. But now, unfortunately, the rear axle has become illegal. So we need to see what we can do about that. We've pretty much run out of ideas at this stage, because we can't do a wheelbase extension. So the only answer here is to reduce the payload slightly. So if I reduce it to, say, 3,800 gallons or 32,000, we're still slightly over 272 pounds over. So I'll need to reduce that further to 31,000 pounds, which then gives us the green light. So that's 3,700 gallons that we can carry in that tank. So as a final check, we need to make sure that that the vertical center of gravity is still okay. So we'll go back to that view and note that that's increased by about 4 inches to 69. So again, we need to just check that it's within acceptable limits, within the manufacturer's acceptable kind of envelope there. Let's assume for this example that it is. So before I send it over to my customer, I'm just going to pin the centers of gravity of those components that I've added to the truck and generate that PDF to send over to them. And that has a nice breakdown of the drawing and all the different components I've added, as well as a weight analysis of each component. So that's it for the second case study. Are there any questions? Are there any questions now?
Yes, Jens, there are a couple of questions here. One is, Bruce just wanted to know if we supported a twin steer configuration for Class 8 chassis, and the answer to that is yes. So on the home screen, when you choose your vehicle, you can choose a twin steer vehicle on there. And then the second question, which has come through a couple of times, was just in connection with the federal bridge law in the compliance scorecard down there on the left. And the question was, do we only validate against federal law, or do we also validate against state-specific laws? So the answer to that is that we have preloaded federal bridge law, and when it comes to state law, for now anyway, we don't have state-by-state legislation in there yet. So you can override your axle limits if you know them for your state. So Jens, if you wouldn't mind just showing where you can override the weight limits for individual axles and for the total, just, yes, where you're dealing with a particular state.
So each permissible there, if you know the permissible for the front axle, you can click on that, and you can override that bridge value there. And I can set that if it's slightly higher or lower. I can just go ahead and override that. If it's 22,000, I can do that. In this case, it won't have an effect. because the limiting factor is the manufacturer rating, or the GAWA. But yeah, as Sarika pointed out, you can tweak those values if you need to.
We do record all of these kind of suggestions and requests. So if there is a particular state that you're after, by all means send it through. If there are enough people maybe requesting state-specific legislation from your state, it would tend to get done before a state which isn't being requested. So please do send through your suggestions. Thanks.
Right, so if I go back to my PowerPoint here. So what have we learned? We've learned that allowed weights across consecutive axles increases with the number of axles and the spacing between them. As we saw in the two case studies, these two strategies probably made the most amount of difference. Adding a pusher axle increased the payload by a few thousand pounds in each case. We also noted that it's important to reduce the rear overhang when speccing dump bodies, as the hinge point needs to be close to the rear axle for stability when the dump is in the up position. When speccing a center axle drawbar trailer, tongue weight is an important consideration. The tongue weight sufficient tongue weight ensures stability and traction on the vehicle's driven axles and the trailer's axles. And then lastly, when it comes to calculating center of gravity, it's very important to take into account each component in terms of its size, weight, center of gravity, and position on the vehicle. That's it for the case studies. If you'd like to register for a free trial, you can do so on our homepage, TruckScience.com. You'll see there's a big green Start Free Trial button at the top right. It'll take you under 2 minutes to get into the app, as there's nothing to install and it works on most browsers. Integrating your NTA details will get you an extended trial of 30 days. We'd also be quite happy to schedule a personalized demo for yourself or your colleagues. So feel free to get in touch if you'd like to set that up. So at this stage, we can open it up to questions. Are there any other questions there, Sarika or Martin?
There's just one more question here from Dwayne. Jens, where do you get your chassis weights from, and how accurate are they? So I've just explained here in the chat that we take them from the OEM's bodybuilder manuals, and if the chassis weights for your particular vehicle differ from what was on the spec sheet or on the bodybuilder manual, you can override them, as Jens has just demonstrated. Where they haven't been provided, we set them to 0 and prompt you to update them.
Yeah. I suppose it's also worth pointing out that if you can't find your particular chassis in the database, you can request that the support team add that for you, and that's all included in the subscription. And you can send on a spec sheet or kind of just specify which vehicle you need added, and the support team can turn that around for you.
There's another question here, Jens. Is there a metric option? So if you could just maybe flick back into the app to show where you can switch between imperial and metric measurement systems.
Yes, so let's do that. So I can go into settings here. There are a few different settings here actually. The way you specify your cab dimensions, chassis dimensions, you can choose either wheelbase or cab to axle. So those of you that prefer to talk about cab to axle or CA, we can cater for that. And I'll just go into measurement here, and we can choose between metric, imperial UK, and imperial US.
There's another question here. Are overall length limits taken into consideration? So Jens, maybe you can show what happens when you exceed the overall length.
Okay, I suppose let's increase the wheelbase here. If I set it to, I'm not sure what would trigger. Are there dimensions? We've triggered a dimension there now. So you'll see all the warnings in here. But yeah, the short answer is yes, it does.
Jens, maybe another useful thing to point out with that is how to switch between specifying wheelbase and CA.
How to specify, right? Okay, so you can toggle here at the settings, and you can just change that to cab to axle, and you'll notice then the next time I open any vehicle, I'll just open that same Kenworth. And you'll notice now that dimension is flagged, so you can change that dimension instead of the wheelbase dimension, which we were able to change before. So you can specify that then and call it 170, and that'll update the drawing for you. Are there any other questions there? Yeah.
There's another question: are RBM calculations available? I just need to check what RBM acronym stands for here.
I see there he's saying resisting bending moment, and the answer is no, we don't do those yet. So we'll go ahead and make a note of that requirement of yours.
There's another question here, Jens. How would we enter our own equipment information into the program? So maybe if you can just point out the import DXF feature on the equipment choice dialog there, please.
Okay, so go to the app, and on my vehicle, I can say I can add a bit of equipment, and I might choose other equipment and import a DXF file. And I'll just choose a file from my desktop, and take a DXF and import it that way. And once I've gone ahead and done that, you can actually save that. And I'll just add a piece of other equipment. It works the same way for the templates, but you can actually save that, save the piece of equipment, and call it ABC equipment, and you can choose to save that in your personal library, or you can make it accessible to your team. So you can build up a database of your equipment items that's accessible to all users in your company, and they can then just select those and drag and drop them onto your designs. There is one further option. If you would like your equipment to be available to, say, salespeople at truck dealerships, you can request that those pieces of equipment to be published, and they would then be available for selection by everyone. But that's only if you choose to do that.
Yes, I think that's it for the questions for now. I'll send out an email later just to thank you for attending and to forward you a recording of the webinar. So if any further questions come up, please feel free to just pop them back to us, and we'll get on to you as soon as we can.
Okay, well, thanks for joining us, everyone, and yeah, stay safe, and hope to talk to you soon.